Okay, so the next topic is about specific heat capacity for monoatomic gas. Monoatomic gases will only have translation degree of freedom. Maximum, they can have 3 translation degree of freedom. Each degree of freedom will contribute 1 by 2 kb, and therefore 3 degrees of freedom will contribute 3 by 2 kb. So by using law of equipartition of energy, the total energy of one molecule of gas will be equal to U is equal to 3 by 2 kBT into Na is equal to 3 by 2 RT. So specific heat capacity at constant volume will be equal to Cv is equal to du by dt, that is equal to 3 by 2 R. For an ideal gas, it will be like Cp minus Cv is equal to R. So therefore Cp is equal to 5 by 2 R. Ratio of specific heats, Cp by Cv is equal to 5 by 3. Similarly, specific heat for diatomic gases, that is rigid. So rigid diatomic gas means there will have translational as well as rotational degree of freedom, but not vibrational, as we already discussed in the previous video. So they are called as rigid oscillator. Rigid diatomic molecule will have 3 translation degrees of freedom and 2 rotational degrees of freedom. So total 5 degrees of freedom. By law of equipartition of energy, each degree of freedom will contribute 1 by 2 kb. So therefore 5 degree of freedom will contribute 5 by 2 kb. Therefore the total energy of one molecule of gas will be equal to U is equal to 1 by 2 kb T into Na is equal to 5 by 2 RT. Specific heat capacity at constant volume is equal to du by dt, that is equal to 5 by 2 R. Specific heat capacity at constant pressure of a rigid diatomic gas is given to be Cp is equal to 7 by 2 R. So ratio of these specific heats will be equal to gamma is equal to Cp by Cv. And specific heat capacity of diatomic gas, which is non-rigid. So non-rigid also will be having equations. So a non-rigid diatomic gas has translation, rotation as well as vibrational degree of freedom. There will be 3 degrees of freedom and 2 rotational degrees of freedom and 1 vibrational degree of freedom. So the total contribution will be like for translation it is 1 by 2 kBt, for rotational it is equal to 2x into 1 by 2 kBt, and for vibration it is just kb. So total internal energy will be equal to, for 1 mole, 5 by 2 kBt plus kBt plus is equal to 7 by 2 kBt, that is equal to 7 by 2 RT. So Cv, that is specific heat at constant volume, will be equal to du by dt, that is equal to 7 by 2 R. Constant pressure will be Cp is equal to Cv plus R, that is equal to 9 by 2 R, and gamma is equal to Cp by Cv is equal to 9 by 7. Okay, so there are 2 independent axis of rotation, that is 1 and 2, and normal to the axis joining the 2 oxygen molecule, and it is also having 3 translational and 2 rotational degrees of freedom, dF. Okay, so coming to the next topic, specific heat capacity for polyatomic gases. Polyatomic gases will have 3 translation degree of freedom and 3 rotational degree of freedom, and F number of vibrational modes. Total internal energy of 1 mole will be equal to 3x of 1 by 2 kBt plus 3x of 1 by 2 kBt plus F kBt into Na. So 3 by 2 plus 3 by 2 plus F RT is equal to 3 plus F RT. So specific heat capacity at constant volume will be Cv is equal to du by dt, that is equal to 3 plus F R. Cp is equal to Cv plus R, that is equal to 4 plus F R. Next 4 plus F into R. Next gamma is equal to Cp by Cv, so relate those two equations. So 4 plus F into 3 plus F. Specific heat capacity for solids. So consider there are n atoms in a solid. Each atom can oscillate about its mean position. So therefore vibrational degree of freedom, which is equal to kBt. In 1 dimensional average energy kBt. In 3 dimensional average energy 3 kBt. So therefore the total energy U of 1 mole of solid 3 kBt into Na, that is equal to 3 RT at constant pressure. So del Q is equal to del U plus P del V. Change in volume is very less, therefore del V is equal to 0. So which also implies that del Q is equal to del U, and we can just conclude that Cp is equal to Cv is equal to 3R. And specific heat capacity of water. So consider water as solid, so it will have n number of atoms. So therefore for each atom average energy will be 3 kBt. So number of molecules in H2O is 3 atoms. So total energy will be U is equal to 3 kBT into 3 Na, which is equal to 9 RT. So Cv is equal to Cp is equal to 9 R. Conclusion on specific heat. According to the classical mechanics, the specific heat, which is calculated based on the degree of freedom, should be independent of temperature. However, the temperature is greater than 0, degree of freedom becomes inefficient. This shows classical mechanics is not enough. As a result, quantum mechanics comes to play. According to quantum mechanics, minimum non-energy is required for degree of freedom to come into play, and specific heats of all substances approaches 0 as T is greater than 0. Okay, so thank you all. Thank you.